On behalf of the PPDM Education Advisory Committee, we thank you for joining us for this, our third podcast in our series on why data management is still important. My name is Barb Richards, and I'm a senior manager at Quorum Software in the data management space that supports our Energy IQ branded products. And I'm happy to be the plus one in our Three Wise Guys plus one today, discussing what is the role of digital technology. We are happy to welcome back our three seriously wise guys who bring over a century of experience and knowledge. Jim Crompton, who after a long career at Chevron and in his Reflections consulting practice, teaches petroleum data analytics at Colorado School of Mines. Jim brings to bear his data management and analytics expertise on our topics. Dr. Tim Coburn is the data science and analytics professor of systems engineering at Colorado State University and a research associate at CSU Energy Institute, and has a long career in both operators and education, bringing that topic to bear. And John Jacobs, who has had a long career in software development at several operators, many operators, and most recently at Anadarko Petroleum. John brings to bear his experience in both services and operators in his consulting practice. We welcome our three wise guys, and we look forward to diving into this topic of what the role of digital technology really is. And what's led us to that point are our first two discussions in our first two podcasts on why does data management matter, and debunking some of the modern myths about data management. So welcome, wise guys, and I'm going to throw it out to you. Why does digital technology matter, and what is the role of digital technology in data management?
Well, if I can start, your reference to a century of experience between the three of us, I think it sounds like we all started with hieroglyphics or something like that as the first SQL code. But the role of digital technology, is clearly as a very significant enabler for us to handle a lot of data, the data volumes, kind of aspects of it. And without that, I mean, the data lakes in the cloud and all the rest of these sort of things, we wouldn't be talking about how much data that we are going for. But to me, the real challenge with regard to digital technology is that it often becomes the only thing that people think about. And while it is a really important step, a really important tool that we have for managing data, ingesting data, doing statistics on data, visualizing data, all of those sort of things, that's made a material difference between tools we had, 20, 30 years ago. It still is not everything that we need. And kind of I think the point that I want to try to make through this is that digital technology is great, but it doesn't replace the need for the data steward, the data curator, the one who understands what the data is really all about, what trust is all about, and in terms of where do you find your data and how do you using it. So it's not that digital technology is bad. It's not. It's very, very good. It's not the only thing you need to think about.
So you're saying technology isn't the answer, that we still have to do something, right?
Somebody has to know what is a well, and before that, we still haven't developed the technology that does that thinking for us.
I might chime in here and say that digital technology is not something new. It just didn't fall out of the sky yesterday. It's been evolving since the 1970s or so, and going forward, sometimes in leaps and bounds and sometimes very slowly. In all of those transitions over the last few decades, we've always had this question about who's going to manage the data. Who's going to keep it correct? Who's going to make sure it's accurate? Who's going to be able to massage it and get it in the right place? And so Digital technology has been an important role. It's played an important role for many, many years. It's just that we seem to be inundated today with digital technology because it's in our face every day, and what we have to deal with. And it perhaps the emphasis is greater there, but the role of the individuals behind the scenes are still extremely important and must be taken into account.
Yeah, and I think I can add to my two colleagues. I mean, what Jim and Tim both are saying is right. I mean, at the end of the day, whether we're digitally oriented or not, you still have to have the knowledge base to get the highest quality of information and data into the system. There is no doubt that digital technology has helped in the performance side in terms of making decisions more rapidly. It helps in incredible ways for us to get important information quicker. And to be honest with you, it has probably saved us, millions of dollars in terms of our ability to turn a lot of our decisions into results. So, I mean, the digital technology is has been a huge windfall, I think, and it's not just in our industry. I think across the board. But at the end of the day, I mean, before digital technology, bad decisions were still made with bad data because you didn't have the knowledge base to handle it. And it still exists today, even with digital data. Digital data did not solve bad data issues. And I think in some cases, it might have just exacerbated it because a lot of people believe, especially in the old days, that once it was turned digital, it was automatically deemed correct, which was false. I mean, and I think we've gone beyond that. I think we've gotten to the point where we realize bad data can exist in any form.
Right. So even back in the days of the hieroglyphics, I'm sure there were bad ones out there, right? We can consume more data, we can create more data, we can generate more data, we can generate more decisions. Digital technology is speeding up the way we can deal with data. So Jim, you mentioned data lakes versus data swamps. What do you mean by that?
Well, the overall kind of, I don't know if it's an invention, but it certainly was a very interesting development of the shared folders, kind of a model for the original data lakes, or essentially it's a way of storing data without structuring it. It essentially, and it really tremendously increases the ingestion speed, as John was talking about, of pouring lots and lots of data because we have so many different sources. We're connecting to time series based data from the field. And so all of this data comes pouring in, and there's no way a human being is going to sit there and examine it before it gets stored into whatever our structure is. So these data lakes provide combined with high performance computing, which can crunch all of these big numbers and these big models, very, very fast, much faster than we ever used to have it. And it essentially creates these large collections. However, and I think this is one of the differentiations between the basic technology and the data swamps, which really kind of brings in the question of data quality. We could bring all of this data in without mastering it, without the contextual information that links, the data from this well to that gathering system to that pipeline to, whatever it is. We lack the mastering, we lack the data quality checks, we lack the other stuff, and that when you don't, and this is kind of both the technology and the human working together. If we don't pay attention to those aspects of data management, which are critical aspects of data management, then we create these very large data collections with enough data errors in them that they no longer are trusted. That you plot them all out and you got all this garbage. Yes, you collect garbage a lot faster than we used to before. We always have been collecting garbage in terms of data quality issues. But in terms of the rest of this, if we let these issues of quality and contextual lack of metadata, all of these things really become an integral part of our data lakes, that's what I refer to as a data swamp.
Right. So it's lacking the metadata, the structure to make sense of it and to allow other things to connect in the right way to make it a master source, right?
Correct. And I think, again, that gets down to the idea of integration. Um, the volume part of big data, which is clearly with us. We have just an insatiable appetite for more and more data as we get in here, unless it's curated and awfully curated by a data expert. Then we can store it on in the cloud. We can process it on the HPC computers. We can still crunch it, but what we are crunching, it's the garbage in, garbage out scenario just on modern technology.
Something we've sort of glossed over here is this about the role of digital technology, and we've mentioned it a couple of times already, is this differentiation between structured and unstructured data. While we have an ongoing growth of structured data, um, it's the unstructured side that really is growing so fast, and that's where the role of digital technology is really important today. And without that, we would just not be able to handle that kind of data. We would have what Jim is referring to here as data lakes and data swamps and data sewers, maybe, if you would take it very far here. You have to have technology in today's environment to handle this kind of information that's so important to us.
Yeah, I completely agree. I mean, part of the advantage I see in some of the digital technology is our ability to actually scan and to pull information out of unstructured data today is, from a performance standpoint, huge. I mean, that's been a godsend, because I mean, probably some of the most important information we have is actually in the unstructured data. And our ability to be able to scan through that, to create indexes, to create tags, and the ability for people to search almost in real time through unstructured data is huge. And it's been a windfall. But again, going back to what we're talking about, if this hasn't been well stewarded, if it isn't managed, you still are going to have a major issue with people pulling bad information out, unstructured or structured. You still have that issue if it's not well managed.
And I think, just to talk about the technology aspect here again, that there is this myth, and we talked about a little bit about last time, that if it's all digital, it's good. If it's processed through the modern technology, it's good. If it comes from a data lake, it's good. When really it's just as susceptible to error as anybody else. I mean, John mentioned this growth in unstructured data, and I think that's one of the things that really has changed over the last maybe 10, 20 years with regard to that. Is, yes, our structured data is very significant, and if the geophysicists were the first ones to break the storage servers with their size of their seismic surveys, but what has happened over the last I remember this was probably 10 years ago, so it's not new news, but we were looking at a data collection, and what data type was the fastest growing. And it wasn't the relational data that we stored in SQL databases. It was the .doc and the .pdf and the .ppd, the ppt, sort of formats. And as we went through it, we found out that, well, the project team was, really rushed to finish their project. They did their presentation, but they didn't have time to go back and really put their data back into the trusted structured sources. So the only place a calculation or a reference that could be found was in the PowerPoint file, or maybe the only place that a critical pressure, original pressure, was found was in a permit document, or kind of things like that. And that builds on John's point that sometimes these unstructured data sources have critical data to our analysis, but then it gets back, well, how do I find it? There's another term other than data swamps that I've read is called dark data. It's kind of data we have, but we can't find it. And that again leads back to this idea of lack of context within the different kinds of data that we're having.
So a lot of this data we've seen ending up in enormous blob stores out there, in servers filled with narrative, filled with documentation that's simply attached to wells and facilities. That data, in order to find things in there, it needs that structure. And you also raised the point of who's supposed to manage all this data. If everyone has access to the data lake and can pour their data into it, who is supposed to make sure it's well structured and well managed? So there's a term that we've heard called citizen data scientists, where everyone out there can access this data and assumes that they have good data in hand. How do we respectfully grow the knowledge of how to properly use data within our industry?
Yeah, if I can start on this topic, it's actually one that I try to address with some of the clients on a regular basis. Part of the issue we run into is not the technology, but the way it's being used. Oftentimes, especially with new technology, our expectations have a tendency to get a little inflated. And so when it doesn't meet those expectations, people immediately say, oh, well, this isn't any good. The technology is terrible. Where in reality, the technology isn't terrible. It's just what you thought it was supposed to do and how you're using it isn't what it was intended to be used for. And if you don't have, again, that knowledge base that understands how to use the technology and in the appropriate place, you're just not going to get the best effects from it. And I think, if you go back and look, oftentimes we have seen really good technology that doesn't make it commercially because people didn't know how to use it.
Right. And the cloud is bringing this data closer to people. It's making it more accessible. And I think that leads to a broader population of folks getting at that data.
Yeah, without a doubt. But again, just because you have it in the cloud, that doesn't mean it's the best. It's, we're back to the same thing is that, yeah, we can increase our accessibility to it. But I think the thing that people have to keep in mind is we need to keep the processes in place to improve the quality of that information.
I always kind of chuckle a little bit when people talk about the cloud to me, because it's clear that people don't know what the cloud is. They think it's some ethereal, fluffy something that data somehow goes into, and all the problems are solved. Things all match up, they all work together, and they fail to understand it's just a big bunch of servers someplace in a building where data is actually stored, and somebody has to put it in, has to get it out. So the integration ideas, the merger of information, the matching of information up doesn't get solved just because it gets stored someplace.
Right. So it's not a magic club.
No, it's not.
Well, gee, I thought that St. Michael the Archangel had the certification from the PPDM, sort of standards, and he was fixing it all as when it got up to the cloud. But this idea, it's kind of two sides of a coin about the data citizen that you mentioned earlier before. There is an argument to be made about what sometimes is called data democratization or data democracy, that instead of our very tightly held confidential data, we should make it more available. And in some ways, as we try to do cross-disciplinary sort of analytics, or maybe life cycle of an asset sort of analytics, that's a good thing, because more eyes on it, more use of it, who knows what new value could be created from these sort of things. But on the other side of that argument, and Barb, you mentioned this when you're talking about sometimes the real critical piece of information I'm looking for, say, take a daily drilling report. is not anywhere in the structured fields. It's in the text column, and it's in the text column in some obscure abbreviation that only a driller might know, or maybe a driller on a particular rig might know. So we need the standards, we need the vocabulary, we need the description of this information before we can really, I think, let it loose for anybody and everybody to try to take a look at it. There's kind of this idea that everybody's a programmer now. Well, this is an interesting thing that if we're teaching young petroleum engineers or chemical engineers, geoscientists, whatever the kind of discipline around that, it is amazing what kind of programming they are exposed to. But there's programming, and then there's programming. I mean, there's programming like Fortran. I mean, that was back there with the hieroglyphics. Fortran and hieroglyphics was where we got our start. But there's the computer scientists use the JavaScript and the C++ and that sort of full programming sort of language, but that's not what the data scientist is really about. There's these new scripting programming, low code programming languages, these user interfaces that do graphical programming by just moving icons and stuff around, that is really easy to use. And it's kind of, again, it makes everything look simpler than it probably should, as John made the point, that we're making it look too simple. So therefore we're making it a belief that everything is fixed. Because clearly, if someone isn't sitting there decoding the abbreviations, if someone isn't sitting there saying, we're going to get rid of some of this data because it's not even realistically possible. We're going to get rid of this data because it's wrong. There's some measurement skill or sensor or something like that went crazy. Then we will be polluting that amount of data that someone can work with. So yes, there's a lot of arguments for more access to data, better access to data, but there's also concern and caution about access to what kind of data.
This also kind of gets into our argument that standards are important as well. We have to engage individuals so that they understand the language, the acronyms, the standardization that's used, and that gets right back to the heart of many of the things that PPDM has been pushing for a long time. People have to understand the difference between A and B, and make sure that apples match up. So this is part of the citizen data science kind of initiative, you might say, that we're trying to promote and to try to influence.
So we've been teaching for a long time, and have brought the next generation of folks into our industry. What are some of the challenges you're seeing in educating this next generation about dealing with data as well as they can?
Well, I don't want to you can get me talking here all day about this. I want to get us off track here, but part of it is just how I would call just data intelligence, just some general knowledge about what data is and how it's organized and how it's structured. Data science today is such a powerful term and such an attractive term to so many people, because there's good money to be had if you're a data scientist. You're in a job, and so everybody's trying to do it, and there are many different levels. And we have to keep telling people that this is a hard science. It's computing and math and statistics and probability and those kinds of things. And it's not just some kind of fluffy go draw a picture kind of response that has to be done here. There's a lot of science here that has to be taught, and that's the biggest challenge, I think, trying to bring people along, for me anyway.
Yeah, I think we run into potentially the same issue. You hear this often when we talk about data. The three blind men looking at an elephant and the description each of them has. So I mean, one of them's got the trunk and he gives a description of that, and another one's got the leg or the tail, and each one of them they don't know they're looking at an elephant. Well, I think this is the same issue we run into oftentimes with what you would refer to as these, citizen programmers and analysts, is that oftentimes they know the math, they know the statistics, but they don't know what that data is. They're just applying their science, but they don't really have a basis of understanding of the data itself and where it originated, what it was, what it really should be used for. They're just crunching numbers and generating, analytics, but is it really based on, or is it of any value? Are these statistics that they're pumping out really worthwhile if they don't have the knowledge base of the data that they're actually using? And I think this is part of the risk. It's also that, we're going back to the point that technology misused oftentimes gets a bad name, and it isn't the technology, it's the use. And so we're back to, if you don't have sort of a pretty foundational understanding of what that data is, and you're using even great science on it, it doesn't mean you're going to get good answers. You have to have those two going hand in hand. You need that analytics, but you also need the knowledge of the data.
So we can use these cool programming tools, these drag and drop programming tools, create beautiful dashboards, and everything looks great. And we've got visualizations, but you're saying they might not be accurate. They might not mean anything if you don't understand what you're dealing with. Yeah.
That's the classic correlation is not causation
Yes.
sort of challenge, because these algorithms plus big computers sitting behind them are incredibly incredibly good correlation engines. But that doesn't mean they correlate. They'll find a correlation, but that doesn't mean it tells you anything about what your problem is. You get back to the education part. The first thing that I try to do is break this myth that if it's digital, it's right. And how I do that is they'll start on a project or a computer lab or whatever it is. I have them go into a raw data set, and there's tools that can help you do this. You don't have to do it from scratch, but the data profiling, look at the statistical, concepts of it. Is it normally distributed? Is it, what are some of the challenges just from the look of the data? And then they realize just how bad all the data is. And then you have to pump them back up again and said, yeah, but you can still use it if you know what your problem is. So, I think the ideal data analytics team, one has a data scientist who's a super programmer. Two, has a domain expert who knows what the problem is that they're trying to solve so that you are doing something useful. And then the third member of that team, which sometimes gets left off, and which is the whole point of our podcast here, is the data steward. They're the ones that know where you get the data from the right place. They're the know where the standards are. They're the ones that know how the data governance processes really should work. You got all three of those roles that come to the table, and you can do some magical stuff. But you leave one of those out, and today we tend to, if anybody gets left out, it's a poor data person. But if they're not there, again, we can crunch all kinds of numbers, create beautiful looking dashboards, as you said, incredibly predictive models that might be biased, that might be just in error. It might create correlations that aren't physically possible in the real world, right? So
and people will make decisions on that data.
And we make decisions on that data. And because we have to do it fast, we better hurry up and without thinking through where the data came from, its lineage, if you want to use that term, the rest of it, then we can make bad decisions faster. But that's not the role of digital technology.
Right. And one of the things we've touched on here is the right training, making sure our data scientists fully understand the data and how to use it. And one of the little cross promotional opportunities here that we'll use for a plug is the fact that PPDM actually has a certification called the Certified Petroleum Data Analyst, the CPDA certification, which is a really great foundational credential for understanding more about data management and appropriate data stewardship, and and really understanding what you're dealing with in structured and unstructured data and good, solid practices for dealing with it. So this role of educating our folks to be, good data stewards is something that we at PPDM are really also trying to encourage.
That's the certificate that St. Michael the Archangel has.
Yes, use the original. So in thinking about a good data scientist, one of the things that we always kind of face, I know when we work with clients, is there's IT people, and then there's the business people, the business sponsors, the data owners, and the data scientists have interesting conversations with the business owners who understand the real business challenges of some of this data. They may understand, for example, that the original coordinate reference system under which the survey was run is really buried in a deep, dark comment in the dark data in a corner somewhere, but the data scientist doesn't know that and may be making an assumption. Have you guys seen that happen before?
Oh, yes, many times.
And how can we get around that? What can we do better to, use digital technology to, bring the business realities together with the, data professionals?
I think what Jim was talking about earlier was part of the key to that is, they need to work in coordination. I mean, it's not a matter of the data scientist being stuck in a dark room and fed information under the door. That's not the appropriate process. He needs to be working in conjunction with your data analyst or your data manager, as well as a domain expert who understands the intended outcome and what it is that they're trying to achieve. They can't work alone.
What really gets back here to context. The fear is that the data scientists will say things that could be totally correct and appropriate, but the business person doesn't understand that, and the communication is not clear. So there is that fear, and I think it's important to all of us to make sure that we as data scientists or analysts or data managers continue to communicate at the level that the CEO and the managers can understand it and say the right things. Otherwise, there is going to always be this disconnect, and decisions will get made, perhaps inadvertently, that are inappropriate. And I think as an organization, we need to promote the communication skills, the data communication skills, as much as we promote the technical skills behind the scenes.
That's a great point.
I think that needs to go both ways so that the data scientists can speak to the business challenges a little bit more clearly so that everyone understands, and the business folks have some better idea what the data scientists are talking about.
Yeah, I perfectly agree with you, but sometimes the business folks don't have the same commitment because they got to make a decision now. The manager's got to go now, and so they're depending on this new hire, this great hire they've got to tell them the truth, and hopefully that works out. But I've seen so many times when the manager takes verbatim what the data scientist says and then converts or convolutes what's been said into something else, and to make things kind of turn out the way they wanted to turn out. That's unfortunate.
Yeah, to back up what Tim says, I mean, at the end of the day, the business manager's got the checkbooks, right? So he controls the language, the vocabulary. Everyone has to communicate with him or her. It doesn't, the manager, she doesn't have to really, understand Python code or the probability theory or whatever it is. So the key thing is business language. And Barb, you're right about communications. There's no doubt about that. I give a lecture in my class that it says really essentially about how to tell a good story with data, to get at that communication issue that we all know we're going to have to go through a PowerPoint presentation or a 1.5 page management a briefing document or something. So how to do that well. But then I follow it up with a lecture that says how to lie with data, or how people might try to lie to you with data. maybe inadvertently with regard to that. And then if people's eyes are the students' eyes are a little bit more open, they can go back and they can look at examples where people are lying to them with data all the time. And it's called marketing, right? And we try to do things like that just to say, even people who are just trying to promote a certain point, you got to look at the data. You got to take it step by step to really understand what you're talking about. But in the end of the day, we all have to speak the business management's language, because more often than not, they make the decisions and they spend the money.
Yeah, I mean, I can give you sort of an example. In software development, especially when you're working with a particular business area, you have to be able to extract requirements from your discussion. And oftentimes, when you directly ask a customer for requirements, what they end up handing you are their idea of an implementation, which oftentimes doesn't really meet the needs that they're looking for. So if you're not able to get down to the meat of the needs and to understand the requirements, and you build exactly what they asked for, they come back and say, oh, well, that wasn't what I wanted. And they're right. Well, it's the same thing in data science and the area that we're talking about. If you don't really understand what the business is asking for, down to the real purpose, and all you're doing is trying to take their interpretation of what they think your job is, you're going to give them the wrong answer. So, part of this, it's a two-way street, and you have to be able to interpret what it is they really need, and you have to be able to confirm that. Okay, it's not a simple process, and sometimes it can be a lengthy discussion until you finally reach an agreement. But you have to do it. You have to go through that process.
That's an excellent point, and I have a sort of a little story to back that up. I'm dating myself here, but I once upon a time was working for a senior exploration manager at a big company whom I will not mention, and he had given us a task to look at a prospect, and we had all these nice digital models and colored maps and all kinds of things. We made a presentation to him, and his response was, with lots of expletives, "Don't you ever show this to me again. All I want is an answer. Yes or no. Do I drill here or do I not drill here? And what's the risk?" And we had completely missed the requirements he was looking at. And that has stuck with me forever, about trying to communicate with the guy who has the money in the checkbook.
It gets back to the Henry Ford quote. He said, when he was trying to put together the Model T, design for the Model T, he said, if I asked people what they wanted, they just said a better horse. But what he really went to dive deeper is what did they need? And then he started beginning to figure out how to revolutionize transportation. With regard to that, it's that wants and needs are different. Almost in a sense, that's why programming has shifted to agile, is because for every week, every 2 weeks, you stop and say, is this what you want? And is this what you want? And then your business representative could actually help that person shape their requirements, as John was saying, if they have trouble doing it at the beginning. So really, it is down to what do you need to make a decision? What do you need to create value? And that's all about requirements. And that's the business language. That's the business role and all of this stuff. But getting back to it is, you're going to have good data processed in the right way, using the smartest algorithms to create that model that gives you that answer. And it's not as straightforward as, oh, I know Python scripting code.
Agreed.
Yeah. I mean, another example is if your business person is coming to you and telling you what regression model to use, and you're the data scientist, you're probably not communicating very well.
No. Or you might get fired.
Or even worse, you'll do what he said, and then you'll get fired.
You're wandering around in the random forest. That was my first AI joke I think I've ever told.
That's a good one. So we are nearing the end of our time together. And I wanted to make sure that we kind of don't leave anything out here. And I have just a short story. For a brief 2 or 3 years in my career, I was a Scrum Master working with a team who had just come off of sort of the waterfall methodology of defining, spending 6 months defining what a system should do and then starting to implement it. And then we realized that the business was changing under us and requirements were vastly different than we envisioned them 7 months ago. And we needed to shift and change. And moving to that agile model was a sea change. Using digital technology and the way we can build things swiftly allows us to then change what we're building. But underneath it all, we still made sure we had a DBA working with us who could make sure we were on track with the correct validation for the data we had. And we had business folks making sure that what we were building still delivered what they needed. Even though we were building it differently, it still needed to perform. And it allowed us to pivot a little bit to what was needed. And I see that happening more and more now as more and more companies are moving to an agile framework to build the technology we rely on. We just can't forget that the data underneath it needs to support those decisions, and we need to be validating that as we go. And even though we might not want to give that CEO all the charts and graphs, and we just really need to give them an answer, it's important that we have that and that we can look at that. If a parameter changes, we can modify it and run the algorithm or model again. So we need that data management. Any parting words, guys, or lessons learned on really what the role of digital technology needs to continue to be in order for us to be successful in our work in this industry?
I think we should keep our eyes open. Technology is going to continue to evolve. And what's on tap today is not going to be on tap tomorrow. It's going to be something new and jazzier, and things are going to move along. So we need to be agile in ourselves in our learning. Even the three of us, the three of us have engaged in lifelong learning as well. And so we have to have lifelong learning as data people, because technology is going to move us in different directions, but the data is still going to be important. We still have to manage the data and make sure the data is right, irrespective of what technology platform we're faced with using.
Yeah, I think I have to, well, no doubt, I agree with Tim. It's the technology doesn't solve all of our data issues, and in fact, if the expectation is that the technology is going to do that, your expectations are way out of whack. I mean, the fact is you still need to have the standards and the data management and the quality processes in place to really get the best out of the technology. In fact, I think we talked about before. I mean, blaming the technology because it gave you a bad answer, and that bad answer was because you had bad data. It's not the technology.
I think you can kind of make an analogy like this to automated vehicles. I mean, those vehicles are just pieces of machine, and they're going to crash if they don't have the right data behind them. The algorithms are using the data and helping to drive the vehicle, but they're based on data, and that data has to be right. If you come up to a stop sign and you don't have a signal to be at the stop sign and you go through it, you're going to crash. So it's the same idea. You have to have, when we're talking about drilling wells and reporting reserves, you have to have the right data in there in order to get the right decision out.
For example, not knowing the highway is closed in front of you.
Yeah. Yeah. Absolutely.
No, I think there's another digital technology is a tool, and it continues to improve, as Tim says, and it's great that it continues to improve, but it's not magic. I forgot where this quote came from, but it said that any technology that is sufficiently far advanced to what we know today seems like magic, and we get lured in by magic. That the tech vendors have a much bigger budget to take managers out for nicer lunches than the data management people do. That's one thing I would recommend, is give the data management people a bigger budget so they can take their bosses out and explain to them that this data, I mean, my experience with data quality means I will never get into an automated vehicle. I'm going to die. I know it. I'm going to die.
Hear, hear.
Exactly. Thank you for that terrifying advice, Jim. So I really want to thank our three wise guys for sharing of their time and talent today. And we hope you will join us again for our upcoming 4th podcast in this series, where we will address the unfashionable truths about data management. If you haven't already, check out our first 2 podcasts on ppdm.org, where there is also a wealth of other really amazing resources for your use and information about the Certified Petroleum Data Management Professional Certification. The CPDA is a really well-regarded cred in our industry, and really will help, and is also available to be done remotely now. So check that out. We'd also love to get your feedback on this podcast and or hear your suggestions for other topics and challenges that you're facing that you think would make a great topic for the 3 Data Wise guys to address.